Okay, so now we have a formula for calculating the derivative of two functions multiplied against each other. It was more complicated than the formula for the derivative of two functions added together. It was pretty easy to go from the sum of two different functions to the difference of two different functions. Adding and subtracting are just opposites. So next stop is going to be the quotient of two different functions. What happens if I take the derivative of a function f divided by a function g? So here, we're writing again in terms of these dependent variables u and v, or if you prefer, f of x and g of x, respectively. So the idea is, what would we get from setting up this difference quotient? Let's just go ahead and assume that both f and g are some functions we do know derivatives for. Well, difference quotient says delta of my function is just change. My x variable is going to change a little bit that I call delta x, or sometimes I call this h when I'm actually calculating limits. My delta of the function u divided by v, well, that's going to be u plus delta u, all on v plus delta v. That whole subtraction, excuse me, that whole fraction minus the original value, u divided by v, right? So I move my x over just a little bit, and I see what's the difference at those two different x coordinates. Just a simple subtraction. Now, it's a simple subtraction for the fraction as a whole, but I need to combine these two with a common denominator, right? One fraction less another. Sure, this is the difference in two different functions, but I actually want something I can perform limit calculations with. So abstractly, I'm going to combine these. My common denominator is v times the quantity v plus delta v. So my first fraction is deficient by a factor of v. So I'll have a u plus delta u, all times v. My second fraction is deficient by a factor of v plus delta v. So I will be subtracting u times v plus delta v. Okay. And I can go ahead and multiply this all out. And what do I have? I'll have a v times delta u on the numerator. I'm subtracting a u times delta v. The denominator is v times quantity v plus delta v. What happened to the rest of those terms up top? When I FOILed it out, they canceled. I have a positive u times a positive v and a negative u times a positive v. Bye-bye, they're gone. Now, to go from my deltas, my differences, to an actual derivative, I need to divide delta of u divided by v by delta of x. And in the limit as delta x goes to 0, I get the derivative. So I can rearrange my fraction, the very same fraction from the previous slide. The numerator is now going to be v times delta u on delta x minus u times delta v on delta x. The denominator of this fraction is v times quantity v plus delta v. Now, this is a step where I might have typed up this slide a bit differently, because I can see here I've actually introduced sort of my double division. What's going on here is that originally the delta x is in the denominator of the whole thing, and we've brought it up into the separate terms of the numerator. Now, the reason for that is since we're taking the limit as delta x goes to 0, I'm trying to get deltas on top of other deltas. That's where this formula is going to give me derivatives. So in the limit as delta x goes to 0, let's go ahead and calculate those limits on the top and the bottom separately. The limit as delta x goes to 0 of delta u on delta x is the derivative of u. Likewise, the limit as delta x goes to 0 of delta v on delta x is the derivative of v. In the denominator, I have one more delta v that's left over. As delta x goes to 0, delta v is also going to 0. So it looks like my numerator is now u times du on dx minus, oh, excuse me. I need to read that screen a bit more carefully. I have v times du on dx. I subtract from that u times dv on dx. This is all divided by v squared. Oh, the typography on this is a little frustrating. That is a v in the denominator. Okay, well, let's have a better time reading these letters differently from each other and go back to the function of x notation. The derivative of the function f divided by g is g times derivative of f minus f times derivative of g, all divided by g squared. This is the quotient rule.